Hello, I am Dr. Jade Mitchell, one of the program directors for QMRA4. In this module, I am going to provide an exemplar teaching case study that was developed from a research case study to provide an example to you as you develop your own teaching case studies. The paper that was used for this teaching case study is entitled Water Reclamation Redesign for Reducing Cryptosporidium Risk at a Recreational Spray Park Using Stochastic Models. For short, we're going to call this case study CryptoSpray Park. It was published in 2011 by colleagues of mine. We will follow the 8 elements from the components of a teaching case study video that you've previously watched. Case learning objectives, case synopsis, the case study story, the target audience, the research methods, teaching plan, which includes development of a slide deck and teaching notes, assessments, and then supporting materials. To develop this teaching case study, there are 4 steps which should be done in order. The remaining steps can be done in any order after the first 4 steps are developed. So the first 4 steps that we're going to approach are the case synopsis, research methods, learning objectives, and the target audience. Everything else will follow. Step 1, the case synopsis. So for CryptoSpray Park, in reading the journal article, one can find that there was a specific case in or near Lake Seneca, New York, where residents or recreators in the area were exposed to cryptosporidium during a particular summer. There was an outbreak investigation that provided some data used to inform the research case study and the research methods in this case. You'll also find that in this particular research case study, the hazard or the target was clearly identified. In some cases, as we know, when there's an epi investigation from an outbreak, that we don't necessarily know initially what the hazard is. In this case, it is cryptosporidium. So in our case synopsis, we're first going to identify the place involved, a recreational spray park near Lake Seneca, New York. We want to identify an industry that this affects. While there may be many, we want to select one. So for our industry, we're going to say recreational water sports, which would apply to water parks or splash pads universally, since this particular case study goes into the engineering design of those types of systems. It happens in the US. The time span is based on one summer because that's the time period for which we have outbreak investigation data provided. The pathogen is cryptosporidium. We very briefly want to describe that hazard. In this case, it's a microscopic parasite that causes diarrheal disease. This is not a full hazard identification, though if that is the goal of or one of the objectives of your teaching case study, you might have students elaborate on the details of the pathogen. For this purpose, in the case synopsis, you just want to name the pathogen and the response or the adverse health outcome associated with it. The dilemma is just a brief description of why this is a problem. This isn't a full problem formulation, but it should describe how this type of scenario could occur. So we start our dilemma here with kids poop where they play. this outbreak investigation determined that there was a recreator. Generally, children are using this spray pad, secreting cryptosporidium after gastrointestinal illness, which resulted in contamination of the water being used in the splash pad. We also provided some additional information in the dilemma regarding the design of the spray pad and how, though it's disinfected with chlorine, like most public pools and splash pads, pathogens like cryptosporidium are highly resistant to chlorine and require additional measures for inactivation. We identify main characters. So the main characters are going to be part of the case story that we will develop in a next step. Here we chose an arbitrary name and an arbitrary character, a young boy, who was the person playing at the splash pad at the time that it was contaminated. We identify a subfield of academia that this case study is designed to teach. This is the target audience. There may, again, be several different target audiences where this particular teaching case study may be useful, but initially we want to start with one particular audience and then potentially move on to others. There's some key terms. These should be similar to those included in the research case study publication. Next, we want to identify the research methods. So we've provided a document that is described as characteristics for components of a QM array. It's basically a list of potential ingredients or methods that might be used in a particular QM array. They will not be used in every research case study or QM array, but your job will be to identify those specific characteristics or components or research methods that apply to the research case study that you're evaluating. So if you look at the annotations on the right of this slide, from the paper, you can see that, again, the hazard is known, that there is outbreak data, which would allow us to calculate an attack rate. An attack rate is often used as an initial point estimate of risk, which we can then go backwards from to determine the exposure dose causing that risk within certain scenarios. So components of this QM array that we've identified are the hazard identification, that the hazard is known, crypto, that the transmission route is also known, it's waterborne, excuse me, and that there's outbreak data from which we can calculate an initial probability of illness to go backwards through our dose response model to determine what exposure dose resulted in that level of risk. For the exposure assessment, we identify some specific exposure factors, namely the ingestion rates that a person playing at the spray park would potentially have. So children may ingest a certain volume of water when playing in a splash pad. We know that this is variable. A source like the Exposure Factor Handbook, published by EPA, has data for different age groups that can be used for such a case study. We also identified the exposure model, which is based on the spray park design and how the water is moving through that system and therefore moving the contaminant, the cryptosporidium, through the system as well. For step 3, learning objectives, these are the things that you will want your student to do with the information provided in this teaching case study. In this case, we identify some learning objectives based on the steps that were taken in the research case study. That may not apply for every research case study that is being developed into a teaching case study. You may add additional components or subtract some. So the learning objectives for this one will be to estimate the dose of cryptosporidium that likely started the outbreak. Students will be able to do this using the outbreak investigation data as was done in the research case study. The second objective is to determine risk associated with playing at the park. So going forward, can we forecast through a QMRA what the risk of infection and illness will be for people who will continue playing at the park after the contamination event? We will have the students identify critical control points within the system where the risk could be mitigated. We will assess the likelihood of risk of infection in future events, and then establish a baseline to compare reduced risk for suggested retrofits. So if we redesign or test multiple redesigns of the spray park, can we use our risk assessment to tell us how effective those designs will be in reducing future events or risk from future events? And then finally, we will have our students recommend a retrofit option to future engineers in order to mitigate these risks. So what they've learned from testing different retrofits, we would like them to be capable of selecting one based on reduced risk. The fourth step in development of the teaching case study is identifying the target audience. So once we've identified the specific learning objectives from the research methods in the research case study, we want to think about what information, skills, or background students would need to undertake this this teaching case study effectively. For this particular case study, we have chosen environmental engineers who have some moderate training in QMRA, so it's already been introduced to them, and perhaps they've seen multiple examples of QMRA being used for other scenarios. We think that the student should be, at a minimum, early career graduate students in environmental engineering, because this particular case study involves engineering design and evaluating different retrofits to determine which will be most effective. Some specific topics that the student should be comfortable with before undertaking this teaching case study include probability theory, some basic epidemiology, so understanding attack rates, odds ratios, relative risk, R naught, and what type of information is gathered during an outbreak investigation, so that they can use the data to meet the objectives related to predicting the attack rates. They should have some basic water system design, including water treatment, filtration, settling, and disinfection, so that they're able to understand and develop new retrofits on their own. And again, they should know the basics of QMRA. So the following steps of this case study are those that don't have to be done in any particular order, but are part of the total teaching case study elements. Writing a case study story. This is where you want to write a story that engages the students so that they have some relatable real-world scenario from which to draw knowledge and interest about the case study. Here we tell a story about our main character and how he was playing at the park after an illness, didn't realize he was still shedding cryptosporidium. Unfortunately, though he was following basic hygiene, the outbreak still occurred because it was basically washing off into the water as he was still excreting cryptosporidium. There was a sign posted to close the splash pad after the investigation, and we need to figure out what the next steps are in terms of reopening the splash pad, or what changes need to be done in order to do that. The next step would be developing a slide deck. And this slide deck might actually be 3 slide decks, because you want to present the case study as an introduction to the students. You want to be able to have slides that convey the specific things that they may not know and need to learn to do the case study. For this case study, Markov chains were used to inform the exposure model and how cryptosporidium moved from parts or compartments of the splash pad design to other compartments, and ultimately to the water that children were being exposed to. And then you also want to have a slide deck that follows up on the case story. So you may not want to give the students the research case study or the peer-reviewed article that you're developing the teaching case study from initially, but at the end, after they've completed the work to solve this problem, you may develop some slides or give them the paper that review what was actually done in the research case study as a way to compare or learn additional things that they may not have picked up on initially. The next thing that you're going to develop as part of the teaching plan are teaching notes. So these notes are for the instructor. They should include a synopsis or summary of the strengths and weaknesses of the case for teaching and learning. They should also point out where students might struggle, and then what additional resources are available to assist or scaffold learning in those areas where we know that students might struggle. For CryptoSpray Park, we identified strengths as being this model built directly from an epidemiological outbreak investigation, and therefore represented a realistic and observed risk. We identified as a weakness that it used Crystal Ball to do the Monte Carlo simulations rather than an open source option like Python or R. Crystal Ball is a proprietary software, so for transparency, we would want to use an open source software that is equitably available freely to anybody who would want to review this case study rather than something that would have to be purchased or owned. Students might struggle here with going both forward and backwards through the dose response model. So because we had an initial outbreak, we started with a risk developed from the attack rate and then identified the exposure dose that would cause that risk. Then going forward to evaluate the retrofits, we simulated from the outbreak what the concentrations of cryptosporidium might be in the water, and then through the new exposure models developed for the retrofits, predicted risk going forward based on those concentrations. So for students who are just learning QMRA and the paradigm and consider a unidirectional linear path through that paradigm, they may struggle with going backwards and then going forward, or knowing when to do one or the other. And then finally, we identify some resources that could help with these points where misconception might occur. Finally, we want to develop an assessment for our teaching case study. The teaching case study is basically a problem, or a big problem, that is being presented to the students. While there are specific learning objectives and tasks for them to achieve, parts of the teaching case study are open-ended and may result in multiple solutions. So we've identified or developed a general rubric, a master rubric, we'll call it, that can be used to specifically assess what should be learned in the teaching case study that you develop. And you'll choose components from this master rubric to fit your teaching case study, and then add to it as needed. This is one section of the master rubric on hazard ID. So, for example, if we want to assess the target pathogens for analysis, in this case, it's Cryptosporidium, and that's the only pathogen that we're concerned with. As I mentioned previously, there are case studies where we didn't initially know what the hazard ID was, or what the hazard was, and part of the case study might be identifying what's the hazard, or which hazard is producing the highest risk. So an excellent solution would be, for this case, that the students identify Cryptosporidium as the target pathogen. If we have another scenario with multiple potential pathogens and they're not all listed, then we would identify this as needing improvement. And then if students were unable to identify the hazard associated with the teaching case study, we would say that their solution is incomplete or inadequate. This is one example of how you can modify the master rubric for a specific case study. Next, we are going to put together a set of supporting materials. These supporting materials should allow an instructor and students to go through the case study and produce a solution or solutions for each learning objective. In this case, we would provide some readings associated with the skills that need to be taught, like the Markov chains, which we anticipate as being new for the target audience. We would provide R code for the Monte Carlo, or for analyzing the epidemiological outbreak data. We might provide some supplementary materials like other examples or exercises of Markov chains, so that the instructor could teach Markov chains separately and then have students apply it to the case study, for example. And then any other materials that would be helpful so that students can produce solutions or results for each learning objective. And that concludes the Exemplar case study walkthrough. At this point, you should be able to develop a teaching case study from a published research case study following the components of a teaching case study video and this example. Thank you.